For years, the whole story of AI has been pretty simple. Bigger is always better. More data, more computing power, bigger and bigger models. It's been this undisputed path to progress. But what if that path is actually leading to a dead end? What if the very foundation of modern AI is starting to show some serious cracks?
And as AI pioneer Ilya Sutskever says, what's really crazy is that this isn't some theory anymore. The massive scale, the huge investments, these incredible capabilities. This science fiction future we've all been talking about, it's happening right now.
But here's the thing. For all the amazing hype, there's a deep, deep contradiction at the very heart of AI. A paradox that suggests that for all this power, we might be fundamentally missing the entire point.
To really understand this contradiction, we've got to go back to the one idea that got us here in the first place, the age of scaling. This has been the single driving force behind almost every AI breakthrough we've seen lately.
Just let this number sink in for a second. We are on the verge of investing 1% of the entire planet's GDP into building AI. That is a truly staggering amount of money and resources, all riding on one single strategy.
And that strategy is what everyone calls the scaling recipe. And look, it's been incredibly effective, because for the big tech companies, it was a pretty low-risk way to get guaranteed progress. You just add more data, throw more compute at it, and boom, the AI gets smarter, simple, predictable. And for a while there, it seemed totally unstoppable.
And when you look at this timeline, you see just how recent this whole age of scaling thing really is. Before 2020, AI development was all about research, tinkering with new ideas. Then, for the last 5 years, it's been a one-track mind. Scale, scale, scale. But that brings up a really critical question. What comes next? Because all the evidence is suggesting the age of scaling is about to hit a wall.
And this brings us right to the core of the problem, what I'm calling AI's great contradiction. It's this bizarre disconnect between what these models promise and their frustrating, sometimes maddening reality.
On paper, these models are certified geniuses. They're getting superhuman scores on incredibly difficult academic tests. But then you ask one to do something that seems pretty simple in the real world, and it just fails in the most basic, frustrating way. So how can something be a genius and an idiot at the exact same time?
Ilya Sutskever gives this perfect, maddening example. So imagine you're using an AI to help you code. You find a bug, you ask for a fix, the AI apologizes, says my bad, and fixes it, but in the process, it creates a new bug somewhere else. So you point out the new bug, it apologizes again, and then it reintroduces the original bug. You're stuck in this endless, insane loop. That's not real intelligence, it's just really fragile memorization.
He explains it with this really powerful analogy. Okay, imagine two students. They're both getting ready for a super hard exam. The first student grinds for 10,000 hours just brute force memorizing every possible question and answer. The second student, they only study for 100 hours, but they focus on really, truly understanding the underlying concepts. So, which one is going to have a more successful career?
The answer's obvious, right? And that's the point. Today's AI is that 10,000-hour student. It's seen basically every question on the test, so its scores are incredible. But it doesn't actually understand anything. It's missing that crucial ability to apply what it knows to new problems it's never seen before. It hasn't learned how to learn.
Okay, so if the scaling recipe has hit its limit, what's the alternative? Well, it looks like the answer is to go back to the drawing board. It's time for a return to real fundamental research.
The old playbook, just throwing more data and more compute at the problem, it can't solve this. We're shifting from an era of just brute force to an era of finesse. The goal isn't just to make the AI bigger anymore, it's about making it genuinely smarter. And the new holy grail for all the researchers is this concept, generalization. It's that magic ingredient, that it factor that the 100-hour student had. It's not about knowing every answer. It's about having the mental framework to figure out new answers. This is the huge leap from shallow memorization to deep, robust understanding. And just look at the contrast here. An AI today needs to see millions of cat photos to learn what a cat is. A child might only need to see a few. A human's knowledge is flexible, it's resilient. And AI's knowledge can be like a house of cards. You change one tiny little detail and the whole thing can just collapse. The gap between them isn't just a difference in scale, it's a fundamental difference in kind.
So all of this is leading the field to a completely new vision for AI. The goal isn't to build a giant, all-knowing oracle anymore. It's to build something far more dynamic and, honestly, way more useful, a human-like learner.
This quote just completely reframes the entire goal of AI. We should stop trying to build an AGI that shows up as this finished product, already knowing everything. The real goal is to create the ultimate student, a super-intelligent 15-year-old, as Sutskever puts it, who is just incredibly eager and ridiculously fast at learning anything. It wouldn't arrive with all the answers. It would arrive with the ultimate ability to find them.
And this implies a fundamental shift in how AI is even built. The old model is pre-training, where you create this massive static brain in a factory, and then you're pretty much done. The new model? It's continual learning. The AI would be put out into the world and learn on the job, constantly adapting and growing, just like a person does.
So this really is the ultimate question for the future of AI. For years, the whole race has been about building the biggest brain possible. But maybe the next great breakthrough won't come from a bigger brain at all, but from a fundamentally better way to learn. And cracking that code, well, that's the great unsolved challenge of our time.